Hello, my name is Tom Rummage, Senior Applications Engineer here at Micro Measurements, and today we're going to give you part 2 of the thin wall pressure vessel, the data acquisition or data acquiring. We're going to be using this pressure vessel containment center, our System 8000 and the StrainSmart Software, and we'll have set up a program over here to evaluate the pressure in the can and direction and magnitude of the stresses. This is a continuation of the 125 URA, the Advanced Sensor Technology strain gauge, proving to you that it works just like any other strain gauge, and in fact maybe even better because of resistance tolerances. And today what we're going to do is we're going to decompress this thin wall pressure vessel, and based on that fact, the Hooke direction, which is typically the larger stresses, will actually be the minimum principal stresses because we're releasing the pressure in the can. That way we will be able to use that minimum principal stress and calculate the pressure change in the can based on thickness of the material, the modulus of the material, and other properties that we have in a user-defined assignment in StrainSmart. Okay, now we're going to start with the data acquisition portion of our thin wall pressure vessel. We'll be using our StrainSmart software in conjunction with the System 8000, and it's going to take that 3-element rosette data and convert it into maximum and minimum principal strains and their directions. And with the calculations within StrainSmart, it will give us the maximum minimum principal stresses. And using a user-defined assignment, we will calculate the pressure in the can. The first step, as always, is to go in and zero, take any offsets that occur out of the system. It says it's completely successful, no errors or warnings. And it's going to go to Shunt Calibration. And Shunt Calibration allows us to take any lead wire desensitization. While it might be very small in this case, it is taken into consideration and taken out of the equation. So now I've done my Shunt Cal. I now arm the system. It's going to go out and ask the scanner, is it okay and healthy to work with? It says no zero errors or warnings, so we're ready to go. I'm going to start, and I've got an online display up here that is going to show us the current values and units and reduction method. You'll notice that grid 1, grid 2, and grid 3 with the maximum principal strain, minimum principal strain, and the angle. And in this particular case, that should come out very close to 45 degrees because grid 1 is 45 degrees from the Hooke direction. It's going to also give us the maximum principal stress, minimum principal stress, the shear stress, and the calculated values based on that user-defined assignment. So now I'm going to go over to the Coke can and depressurize it. Now you go look at the values. Post depressurization, let's look at the values we achieved. The first one, and the one we were actually looking for, is the pressure in the can. That comes out to the 52.8 psi, which is nominally correct. The pressurized can was supposed to have between 45 and 55 psi in it. We have the grid 1, grid 2, and grid 3. Notice that the principal strains don't have any relationship directly to those those measured strains. The calculation gives you their magnitudes. The angle from grid 1, which I said should be around 45 degrees. In this case, it's 44 degrees. Big deal. The shear strain is shown. The maximum principal stress, the minimum principal stress, the shear stress value, and again, as we talked about, the calculated pressure value of the can. So in this particular case, our can had about 50 psi of pressure.